And welcome to video number 145 on our Unit 1 test-113. This is a help video. Video number 145 will begin with question number 27 through 32. These are true-false questions. Compounds can be both molecular and crystal lattices. That's true. Compounds are two or more different elements that join up. Generally, if compounds have atoms join up and they're sharing electrons, they're free to move around independently of one another. That's a molecule. Compounds can also form where electrons are transferred. That's an ionic bond. Ionic bond means one atom takes an electron off another. The atom that takes the electron is the anion. It becomes negative. The atom that loses its electron lost something negative, so it's left positive. It's left positive. And this positive electron, or this positive ion, will attract the negative ion, and they will begin lining up, positive, negative, positive, negative. So the positives attract the negatives attract the positives, they all line up. That's what a crystal lattice is, a regularly repeating pattern of ions. Molecular substances, once again, are when electrons are sharing, or when atoms are sharing their electrons, and they can form a molecule. That sharing of electrons is called a covalent bond. At the time of alchemy, all matter was believed to be made up of the four fundamental natural elements of earth, air, fire, and water. That is true. Those of you that have studied history know that that's like what the Greeks believed. The four natural elements. They thought every substance was made up of earth, air, fire, or water, and the combination of those four things to make every form of matter. And that's why alchemists believed that they would have the possibility or ability to make gold out of other metals, because they believed gold was some type of compound made up of earth, air, fire, and water. They just needed to unlock the right recipe for gold. We now know gold is not a compound at all. It is actually one of the elements. It is a simple, pure form of matter. Table salt's a pure substance that could only be separated by chemical reactions. Number 29. That is true. Pure in chemistry means one thing is there. So if I dump out table salt onto the table, the only thing there is sodium ions and chloride ions together in a giant crystal lattice. One thing would be there: sodium chloride, table salt. Now, if I poured water on the table salt and the water began to dissolve the table salt, now I would have water there and table salt there. That would now be two things there. It's no longer pure. That's a mixture. Sulfur in its elemental form comes in eighths. Phosphorus in its elemental forms come in fours. That is true. Those are elements where the atoms tend to join up in groups. Sulfur is eighths. Phosphorus, they join up in fours. True. I always remember sulfur's 8 because the letter S sort of looks like an 8. I always remember phosphorus. Phosphorus comes in fours. Each element has its own unique atom type. That is true. What determines its own unique atom type are the number of protons, which are positive. Here we wrote number of P with a positive sign. That's the symbol for a proton. The number of protons is called the atomic number. The number of protons in something, in an atom, determines what element it belongs to. So any atom that has one proton in the nucleus is hydrogen. Any atom with 2 protons in the nucleus is helium. Any atom with 6 protons in the nucleus is carbon. However, if the atom has 7 protons, it's not carbon, it's nitrogen. If the atom has 8 protons in the nucleus, it is oxygen. Any atom with 8 protons in the nucleus is oxygen. Every atom has its own type of atom, and what makes that atom special are the number of protons, the atomic number. We mentioned that some atoms come in 8, like sulfur. Some atoms come in 4, like phosphorus. Elements Sulfur is an element that comes in 8 atoms. Phosphorus is an element that has 4 atoms always joined up. Some elements will always have 2 of its atoms join up. Di for 2, atomic. Diatomic means 2 atoms have joined up. Chem 1 students should know that there are 7 diatomic elements. These elements always are found in 2s: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those always come in 2s. Now, oxygen can come in other numbers other than 2. In fact, oxygen can be found in 3s. That's called ozone. Ozone are 3 oxygens joined up. But on the surface of the Earth, oxygen, by and large, is found in 2s. That's its most stable form, and it's a diatomic element. We move on to this great, exciting group of questions right here, dealing with these drawings. We have container 1, container 2, container 3, container 4, and container 5. The first group of true-false questions here pertain to container 1. Pertains to what is in container 1. All right. I'm shrinking this down a little bit so we can see container 1 as we're answering these. Container 1 would be best described as a mixture. In chemistry, mixture means 2 or more different things that are placed together. So in this container, I have 2 things placed together. I have the square element in there. I call it an element because those little black ones are representing an atom, and they're not touching these things. When they're touching, as it said in the directions, they're assumed to be bonded chemically. So I have these things that are going around on their own, and then I have these group of 3 atoms going around on their own. So I have a group of 3 different, and there's 2 or more different atoms on there, so that's a compound. So I have a compound in here, that's one thing, and then I have an element in there, that is another thing, so that is not pure, that would be called a mixture. Letter B, container 1 can only be separated chemically. Oh, no, no, no. You need a chemical reaction to tear apart things that are joined chemically. So it says right here, if they're touching, they're joined chemically. I would need a chemical reaction to tear apart these things. But the squared ones are not attached. So they are not joined chemically. They are just physically placed together. So I could physically pull them apart. I might be able to separate them with a filter. I might be able to heat them up. One of them might boil at a different temperature. There's all different ways I could separate this mixture. Number 3, container 1 has a compound and element in it. We just said that. The element are these ones that are not joined up with anything different. When you have all the same type of atom, it's an element. When they're joined, 2 or more different ones joined, it's a compound. So I have an element in here. That's the black squares. I also have a compound in there. That's the 2 yellows on the clear circle. Number 36, this arrow right here is pointing to an atom. That is true. Atoms are the smallest particle of a substance that has the properties and characteristics of that substance. So the element that would be represented, the element that is this little black square, all the properties of that element would be reflected in the properties of these individual atoms. All right. Container 2 is the next group of questions. Here's container 2 right here. Container 2 had these black ones separated physically, and there's the compound that was separated physically. So now I have all the black ones. I only have one thing in there. So container 2, it would be pure. Oh yes, pure just means one kind of thing in there. That's pure. There's only one kind of thing in there, the black squares. Each atom in container 2 has the same atomic number. That is a fact. All atoms of a given element must have the same number of protons to belong to that element. And now some questions about container 3, which is this container right here. Container 3. Container 3 would have to be broken apart with a nuclear reaction. Oh, no, 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 no. A nuclear reaction is used to change one atom into another atom. We see here that the yellow ones came out and they're now together. The white ones came out, they're together. I still have the yellow ones and the yellow triangles and the white circles. So they have not been changed into another element. That would not be a nuclear reaction. If this is a nuclear reaction, I might have to have the circles change into like a pentagon shape, and then the triangles might have to change into a hexagon shape. No, no, no. They're the same ones. The same atoms came out that were in there. That would be a chemical reaction. In order to tear apart a compound, you must use a chemical reaction if we're going to undo things that are joined chemically. To undo things joined chemically requires a chemical reaction. The contents in container 3 are pure. Pure means one kind of thing in here. We do have one kind of thing in here. I have the yellow one joined with, or I have two yellow ones triangles joined on a circle. Oh man, here's another two yellow triangles joined on a circle. What I have in here are yellow triangles joined on a circle. That is one kind of thing in there. It doesn't matter that they're joined. They are joined into one kind of thing. That's what pure means, one kind of thing. The brackets are a molecule, number 41. Yep, that is definitely a molecule. A molecule is anything joined and they're able to go around independently of something else. That's what a molecule is. 42, the contents in container 3 are a mixture. No, 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 they're not a mixture. They are pure. You can't be pure in a mixture. Mixture means two or more things in here. I only have one thing in here, circles with triangles on it. That's one kind of thing in there. Container 3 is a compound and it is pure. Number 43, physical and chemical properties of the substance in container 3 would have the same properties of the substances in container 4 and container 5. Oh, no, 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 no. A compound has its own unique physical and chemical properties different than the elements that make it up. This compound is made up of the yellow triangles joined together with the clear or the white circles. This thing has its own properties different than these things. When these things join up, the triangles lose their properties and the circles lose their properties, and they end up with something with its own unique set of properties. 43 is false. And we go on to container 4. The contents in container 4 would be diatomic elements. Di means two, atomic means atoms, element means they have to be the same atoms. So we look in container 4, yep, there's two atoms joined and they're the same atom. That is a diatomic element. Question 45. The bracket identifies a molecule. Once again, a molecule is any example of something joined. Oh, there they are. They're joined and a molecule is able to move around. It is on its own. It's not a regular repeating pattern of ions. A regular repeating pattern of ions is a crystal lattice. These are not ions. They are just joined and they're moving around. They can be the same atoms joined. That's a molecule. Or as this bracket is pointing to, they can be different atoms joined. That is a molecule. And our last one on this thing, the substance in container 4 is a compound. Oh, no, no. Compound is different. Two or more different atoms joined. These are the same atoms joined. That's an element. This is a compound because they are different atoms joined. Container 3 is a compound. That brings us to a close of this video 145. Video 146, we'll start with question 47. Thanks for watching.